All right, today's lesson is 11.1, Measures of Center and Variation. We're going to be looking at how can you describe the variation of a data set, and we'll also compare mean, median, and mode and determine the range and standard deviation. So first off, measure of center is the measure that represents the center of a data set. Measures of center you've actually already learned in earlier grades. Those are just mean, median, and mode. They're all measures of center. So the mean is the average, or the sum of the data divided by the number of data that there are. The median is the middle number. And the mode is the data that occurs the most often. And an outlier, we've actually talked about earlier this year, that is a data value that is either much greater than or much less than the other values in the data set. And a little bit more vocab. The measure of variation is the measure that describes the spread or the distribution of a data set. And the range is the difference of the greatest value and the least. So it's the highest number minus the smallest number. And then standard deviation is a measure of how a typical value in the data set varies from the mean. So remember, the mean is the average. We're looking at all the other values, how much they vary from it. So the average difference between the data sets and the mean. All right, so example 1, comparing measures of center. An amusement park hires students for the summer. The students' hourly wages are shown in the table. So that's this table here. Part A, we're going to find the mean, median, and mode of the hourly wages. So for mean, reminder that that's when we add them all up and divide by how many there are. There are 8 data points. First, we need to find the sum. So we're going to add all these together. So 16.5 plus 8.75 plus 8.65 plus 9.1 plus 8.25 plus 8.45 plus 8.25 plus 9.25 is 77.2. That's the sum of all 8 wages. We're going to divide that by 8, and we get 9.65 is the mean hourly wage. All right, and the median is the middle number. I like to find that when we have a table by crossing off the highest and the least and just switching until we get to the middle number. So the highest wage is 16.5. The lowest wage is 8.25. Second highest is 9.25. Next lowest is 8.25. Next highest is 9.1. Next lowest is 8.45. So then our median is going to be right between 8.75 and 8.65, or our median is 8.7. All right, and then the mode is the number that occurs the most often, which in this data set is 8.25. So part B, which measure of center best represents the data? In this case, we're going to say the median, because the mean is a little higher than we would like it to be, because 16.5 is kind of an outlier. It's much higher than the other numbers. And then the mode is actually the smallest number. So the median, the middle number, is the best measure for the center of the data. All right, part C, the park hires another student at an hourly wage of 8.45. How does this additional value affect the mean, median, and mode? Well, if we recalculate all of them, we get 9.52 for the mean, 8.65 for the median, and both 8.25 and 8.45 for the mode. I still think the median is the best measure of center, because even though there's 2 modes and they both cover quite a bit, those are the lowest 4 data points. And the mean is higher than all but the highest data value. So the median, the middle number, is still the best measure of center. All right, so example 2 tells us to consider the data in example 1. I went ahead and copied it up here just so that we could see it. Identify the outlier. The outlier, which we talked about in example 1, is 16.5. That number is much higher than the rest of the data. So we identified it. How does the outlier affect the mean, median, and mode? Well, to answer this, we're going to calculate all of them without the outlier. So now for the mean, add up the other 7 data points and then divide by 7. After you do that, you should get 60.7, which divided by 7 is 8.67. The median, the middle number, let's see, our top 3 data points are these 3. Our lowest 3 data points are these 3, so our median is 8.65, and our mode is still going to be 8.25. So describe one possible explanation for the outlier. That student, the one that makes 1650, could maybe be a manager. They maybe could have been working there for more years, or they could be older than the other students, but clearly they make more money than the rest of their peers. So how did that outlier affect the mean, median, and mode? Well, if we go back to our data from example 1, all of them were a little bit higher except for the mode. The median was only 0.05 off, which makes sense that we use the median to use the measure of center. Then the mode is the same, but it's still the lowest number, and the mean this time is much more accurate. All right, example 3, finding a range. 2 reality cooking shows select 12 contestants each. The ages of the contestants are shown in the tables. Find the range of the ages for each show. Compare your results. Well, the range is the difference between the highest and the lowest data point. So first, we need to find the highest and the lowest number. The highest number in show A is 31, and the lowest is 19. The highest age in show B is 48, and the lowest is 19. So to find the range for show A, we're going to do 31 minus 19, which is 12. And for show B, we do 48 minus 19, which is 29. So the range for show A is 12, and the range for show B is 29. When we compare our results, we see that show B has a larger variety of ages. All right, the second part of our notes, we're going to be using Graph and Calc. So if you haven't figured out how to use Graph and Calc yet, refer back to the directions on Canvas. They're in the first day of distance learning assignments under 8.3, or you can email me for help. So calculating standard deviation by hand. The standard deviation of a numerical data set is the measure of how a typical value in the data set differs from the mean. This was in our vocab for today. It's the difference between any number in the data set, the average difference between that number and the mean. This is going to be shown by this symbol in Graph and Calc, and you can use this fancy long equation to find the standard deviation, or you can have a calculator do it for you. We're not going to use that equation. We're going to make Graph and Calc do the work for us. So I included an image from Graph and Calc right above our steps we'll be following that are actually covering up the steps for the equation. So step 1, you're going to push the stat key. That stat key is right there. The stat key will lead you to a screen that looks like the next image there. You're going to click Edit at the top, which will lead you to a screen that looks like this. L1, L2, and L3 stand for the different lists. So you're going to enter in your data points, push enter after each number to keep going on the list. We're going to use L1. Once you have your lists in, then you're going to press Stat again, but this time you're going to click the Calc tab. Calc will lead you to a list like the image at the bottom left corner. From here, you're going to click One Var Stats, and that is going to lead you back to the calculator screen, where you will then press second and then 1 so that you can enter L1. You're now calculating variable stats for list 1. Hit enter, and that will lead you to this screen. Now at the bottom right, 1 var stats for L1, and the standard deviation is the number here represented by this lowercase Greek letter x, or sigma x. All right, so now we're going to practice finding standard deviation. So first step, use your graph and calc, click Stat, then click Edit, and then enter your list data. Because there are two separate lists of data, show A and show B, I entered show A into L1 and show B into L2. So you have two separate lists of data. Then, to find the standard deviation, you're going to go back to graph and calc, hit Stat, and this time hit Calc, which will bring you to this list again where you're going to click var stats, which will bring you back to the graphing calculator where you're going to click second and then enter L1, which will bring you back to this screen, and then you can tell which one standard deviation is by looking for the sigma x. So our standard deviation is 4.2, that number, but we're just going to say 4.2. So for show A, our standard deviation is 4.2. Follow the same steps for show B, and you will be brought to this screen where you can tell that the standard deviation is 7.4. So we're going to go back up here and say show B is 7.4. So just like we said when we calculated range, that show B had a bigger variety of ages, we can now say with certainty that show B has a bigger variety of ages because when we compare the standard deviations, show B, the average data set, the average data point is 7.4 years away from the mean number of years. So because the standard deviation for show B is greater, it means that each data set is farther away from the mean. What can you conclude from the data? Same thing, show B has a bigger variety of ages.